So before I move to my PPTs, so let me give you some background. So IP address, IP address. So why it required as you know, the two systems, okay, in the computer world, in the networking world, when two computers want to communicate to each other, okay, via cable or via wireless, so they need two types of addresses. Okay, one is a MAC address, which is nothing but a permanent address, which will be vendor defined address, right? So MAC address, okay, and the another address, which is also called as a physical address, and the another address is called as a IP address, which is called as a logical address, and it will define by you as an administrator. So these two machines, if they want to talk to each other, then they want to share the data or something, so they need to know each other's MAC address and the IP address. So without IP address, your machine will not be considered into the network. So IP address is very important. So what is the IP address? So IP address is a logical address, okay, and there are two types of versions, okay, IP address versions. So there are two types of two versions. One is IPv4, okay, and second one is IPv6. So what is the difference between IPv4 and IPv6? So IPv4, it is a 32-bit IP address, okay, and IPv6, it is 128-bit IP address. Okay, so IPv4, it has some limitations, okay, and due to the less numbers and increasing the internet, increasing because nowadays, if you look at here, like all the smart stuff, like you have smart fridge, you have smart AC, you have smart home stuff. So nowadays, like in the future, every device you will have IP addresses, okay, and in the network, like nowadays, like in previous era, like every one person, he used to have one system there, and that will be permanent IP address. But nowadays, a employee, he will have a laptop with him, he will have a tablet with him, he will have mobile with him, he need a guest Wi-Fi, he need a Wi-Fi, he need a LAN. So he will consume multiple IP addresses, one person, one employee. So just think about, now we have a printers, we have scanners, we have IP phones, like we have wireless controllers, we have wireless access points. So all these network equipments, servers, all these network equipments, they require an IP addresses. Okay, so in the world, throughout the world, they like wherever they are into the network, so they need a they need an IP address. So, and you know, the IP address range is any number between 0 to 255. That's it. You cannot take any number, and which will be in the 4 octet. So you will have 8 bits, 8 plus 8, 8 plus 8 plus 8. So like this, you will have 4 octet, okay, and uh, like 8 plus 8 plus 8 bit 8 bit 8 bit is equal to 32 bit, right? So let's say, for example, when we say 192.168.10.10, so this is nothing but an IPv4 example, okay, which has a like this is called octet. 192 is a 1 octet, then dot, then 168 is a octet, second octet, dot, then 10, and you have a 10. So like this 4 octet divided into the 4 octet. So you know, in the octet, the limitation is 0 to 255 only. You cannot take a minus number, and you cannot take a 256, or you cannot take 300 something. So if you say something like 300 and some IP address like 300 dot minus 1 dot 256.400. So this is an invalid IP address. Why? Because the IP address should be between this range, IPv4, 0 to 255. Okay, and the IP address we define into the decimal number. So there are two types of number. If you are from the engineering background, you will come, you maybe know about that. There are two types of number. One is a binary, which computer understands zeros and one. Okay. And another one is a decimal number. Decimal number is nothing but like 1 to 9, and we will have a character like A to F. So this is called an decimal numbers. So here we define IP addresses were defined with the numbers. Okay, decimal number. Actually, in the background, it will be a binary number. So how it get converted and how you will how you can convert from decimal to binary. So this all basics are needed for the IP addresses. Okay, so that's one thing. Then IPv4 has some limitations. Okay, what is the limitation is? Guys, I'm getting some noise, so please mute if you're not talking. If you have any questions, so let's have after this once I finish, then you can ask the questions. Okay, because now I'm in one direction, so I don't want any distractions to so that I can forget what I was saying. So I need some focus so that I can grab the information from my mind and I can share with you guys. Okay, so with that, so 0 to 255, this is a small number only, right? So and with this limitation, so one day the IPv4 will get finished in the world. Okay, and as you know, the IP address will be one IP address you can provide into one network. Okay, and if you provide the similar IP address to the two machines, you will see a duplication. It will give the error. This is a duplicate IP address. Okay, it is already assigned somewhere. So with that limitation, IPv6 came into picture. Okay, IPv6 is something 128 bit, which is nothing but we can say with the IPv6 they said this IPv6 has this many number that you can assign IP address to every item in the planet. Every item in the planet. This many IP addresses, like 3.4 billion IP addresses you will see here in the IPv6. So it is also called as a future IP. And it was actually since 10 years, I'm saying it is a future, but still, but nowadays, many organizations, they started using the IPv6. So let me give you one example. Okay, so if you go to the Google, okay, so let me take that. One second. NS lookup. I know you are not seeing that screen, but fine. I will just get you that result. NS lookup facebook.com. Okay. NS lookup. Okay, perfect. So now the result I'm getting on the notepad now. Okay, now look at here. I just did what I did in the CMD. I put this command. Okay, NS lookup facebook.com. You can use any URL. Like this is called actually the DNS. Okay, what is DNS? DNS is the IP address to the name. Okay, so a human mind cannot remember the IP address. So if you look at here, see when you put this NS lookup facebook.com, google.com, youtube.com, so you will see an IP addresses there. Okay, you will see the what is the IP address. So can you see the facebook.com IP address is something this one, 31.13.79.35. So if you try to browse it like in the browser, so instead of Facebook, a human mind cannot remember the number, right? That's why a DNS protocol came into picture, domain name services. What it does is it assign IP to name and name to IP, right? So this number human mind cannot read, cannot memorize. That's why in the server operating system, like there is a feature called NS lookup. So you can mention this is the IP address and its DNS is facebook.com. So now you can facebook.com, you can, when you browse it, actually that is nothing but a server. Okay, and it has an IP address. So in the backend, you will see this IP address. So this is the IPv4, and can you see this is the IPv6? So the same thing you can try it in your machine. You can try for the YouTube, Facebook, YouTube, Instagram, whatever it is, whatever the URL you see, just always just try to do the ns lookup, this command, and you will see, you will find what is the IP address. So can you see here? So this has IPv4 as well as IPv6. So can you see how the IPv6 number look like? See, you can see that these are the decimal format. So you cannot see something called Z. You cannot see. So the numbers should be A to F, between A to F, and the alphabet should be between A to F, and number should be A to 1 to 9 only. So this is IPv6, which is very, very advanced stuff, and there are books written on that, how to create the IPv6, how to subnet the IPv6 and all. So similarly, there are books written on the IPv4, like how to do the subnetting of the IPv4, right? So we are at this stage, we no need to go into that details, but as a network engineer, as a system engineer, so you need to know a basics of the IP addresses, like what is the IP address, how it look like when you assigning the IP address, understanding the network. It is belongs to this network, this belongs to this network. So this is what my expectation from this class. Like I'm not giving you something like extra thing, because as I told, IP addresses, like books are written on that. So it is not possible to sync everything with that. But there are n number of YouTubers. They have deliver a beautiful lectures on the subnetting and all. So you can always go and refer with that. So I'm not saying like, because everyone may have different method to explain to do the subnetting and all. Okay. So now with that, let's go. So we are not looking into the IPv6. So we are looking into the IPv4. Okay. So now the first thing, okay, in my previous session, if you look at my lecture 1, okay, the study is something I share with you. So in that I define, so there is something called IENA. Who is responsible for the IP address? Like who own the IP address? So Internet Authority. So this is the international organization. So they are the owner of IPv4. Okay, they are the owner of IP address. Like every IP address is a cost. Okay, you need to pay for it. Okay, so now you will think that how can you pay that? Okay, and why you need to pay, right? So to understand that, you need to look here. So IENA, so they are the owner of IPv4. Like all the numbers 0 to 255, any IP address in the world, if you are using, that should be paid. Okay, you cannot so that should be paid. So now you may ask, so every single IP address is a paid, though. Then if suppose you want to you have 100 systems, so do you need 100 IP address to buy? Then how much it will cost? It will be very costly, right? So that's what, so IENA, what they did is they divided these IP addresses into the class. So this is called class of IPv4. Okay, so class A, class B, class C, class D, and class E. So they said any number start from 1 to 126 or 127, 127, let's say. So any octet which start from 1 to 127 is a class A IP address. Anything start from 128 to 191, it will be class B, and any IP address would start from 192 to 248 will be class C, and class D and E, these are the experimental purpose. Like you cannot use that. You cannot use any number like 249 or something like this. Those 249 plus. So this till what is the end of our IP address? So 254. This is the end. Okay. So class A, B, and C, only these three classes are usable. Okay. Rest, these all are class D and E. They are kept for the future purpose. Okay. So now look at here. Now we are using in the world, we are using class A, class B, and class C of IP addresses. So now what is this number? It means the IP address. If you look at the IP address, the first octet, if you want to know the IP address belongs to which subnet, which class, so look at the first octet. If the first octet of the IP address, the number, it is between 1 to 127, then it's a class A. If the IP address start from 192 or any of this number, then it will be class C. And if IP address is then it will be class B. So now can someone unmute and tell me what you think this IP address belongs to which class? The Facebook IP address 31.13.79.35.
Class A, sir.
Okay, so
Class A.
how you, okay, that's fine. So how you understand that?
Because the number is
Looking
less
at
than
the first octet.
127.
Perfect. So you need to look on the first octet. So this is the class A. Okay, so now let me give you some more example. 172.32.132.6.6. Which class it is?
Class B.
Class B.
Perfect. 198.6.5.1.
Class
Which
C.
class?
Class C.
Class C.
Okay. 1.1.1.1. Which class it is?
Class A.
Class A.
Okay, perfect. So now you guys become an expert now.
Mashallah.
Okay, so class A, B, and this is the class C. Okay, so now you need to understand, like the first octet will define it is belongs to which subnet. Okay, so this is now you understand, like you can look at any IP address and understand. Okay, are you able to see the CMD command which is on my screen? No, right?
No, sir.
No, right? Okay, fine. So let me get some more stuff here, like google.com. Okay, perfect. So this is a google.com. Now let's see who will identify first. This is belongs to which subnet, which class. Here we go. .142.
Class B, sir.
The class B.
Class B.
Class B.
Perfect. So Google is using the class B. Facebook is using the class A. Okay. So now you got a basic understanding of the IP address. So any IP address in the world, if you look at the IP address, so the first octet will let you know that it is belongs to which class. And we have three classes only, class A, B, and C. Okay. And the number is between 0 to 255 only. Okay. I have told you, like this is an invalid IP address because 300 is not in the range of Ipv4. Even 256 also, it is not a range of the Ipv4. So it will be the number between 0 to 255 only. Okay. So now this is the second rule, which you need to understand. So these are the classes. Okay. Now the next thing is what IENA did is they divided IP address into the two part. One is a private IP and second is a public IP address. So what they said is we have a private IP address and public IP address. So if you use a private IP address, then it will be free. Okay, free bole to apni public pehle bhagti ho, right? So public means it will be cost. So when to use a private address and when to use a public address? Good question. So in the organization, okay, we use a private IP addresses. Okay, where we no need to charge for that. We no need to. We will not have any cost for that because we will have thousands of systems. We need thousands of IP addresses. So for that, you no need a public IP address. You can use a private IP addresses. So what they did is they reserve some IP addresses for the for private range. So what is that reserve? So they said in class A, 10.0.0.0/8. This IP address range, it is completely free. Then from the class B, 172.16.0.0/16, this subnet from class B, it is completely free, muft. And class C, 192.168.0.0/24, this subnet is completely free. So this is private IP address range. Okay, private IP address range which don't require any cost, free. Okay, so you no need to go anywhere outside to buy this, because you can within your organization you can use this subnet. Okay.
So what is /8/16?
Yeah, I'm coming to that point. So that is nothing but that is called a slash notation. Okay, or that is what the subnetting will come into picture. Okay, so this slash, what is /8, 16, and 24, we will see in a few minutes. So any number, if you look at 10 dot, see in the organization, if you go to any organization in the world, okay, and just put ipconfig/all or ipconfig to see the IPv4 address, so you will find either 10, either 172, or either 192. Okay, it means you will use class A, B, or C. So now that's one, and rest every IP address. So if suppose I'm using 11.1.1.1, is it a private or public IP address?
Sir, public.
Perfect. So first octet, look at the first octet.
Yes,
Okay,
it's 11.
now yeah, 200.192.42.65. Is it a private or public IP address?
Public ID.
Perfect. So how you identify that?
It's, number is 200, sir.
Exactly. So
Yeah,
this
the
is
reserve number is 192 highest.
perfect. And when I say 172.16.1.1, so which class is it a private IP?
It's private, sir. It's private.
Private.
192.168.10.10.
Same,
It
private.
is a
Private.
private IP address.
It comes
So
under the reserve.
exactly, it comes under the reserve. So this all IP addresses which start any range apart from the above, like the private IP address, they all are free. So let me make it green color so you can have a look on, like understand this. Okay, so this is free. Okay, any IP address start from 10, 172, and 192, they are free. Rest every IP address is a public IP address. Okay, so now the question is, why we need a public IP address, right? So that topic we will see like when we do the routing. So that time we will see that, because we may have some server which we need to host for internet world. So that time, like from internet, the people want to connect to your server, that will be public IP address. So that time you need to purchase a public IP address. But with these machines, like when you put these IP addresses, so you're not expecting if any person from internet is trying, they cannot access your machine. So for example, if suppose you use on the system of one of our PSF office, okay, and you provide me the IP address. So from my home, I cannot ping to that IP address. Okay, because we use a private IP address because I may have the same IP address at my home. Okay, private IP address to private IP address connectivity over the internet is not possible. Okay, even from the public to private is not possible. So the only thing is you can if you have something IP address called, you purchase one IP address from IENA 11.1.1.1 something. So that IP address I can connect from my home to that machine. Why? Because that machine has a public IP address. So anyone from the internet, from the world, they can access that IP address. So the same thing, you will see in the AWS. That will again you will get more clarity on into that, like how to what is the private and public. So the ground formula is The private means it will be a private. It will not. A public means a public, right? Which is open for the world, and private is within your organization. Okay, so that's the main difference. So now coming back to this point. So now we understand that class A, class B, and class C. So these three classes we have. Okay. So what is this /24? So the subnetting, or there is one with the IP address, you will see one term called subnet mask. Okay. So the subnet mask is something called like for the class C, the default subnet mask for the class C is 255.255.255.0. So
Zero.
okay, yeah. So why it is 24 is because if you look at, if you count the bit 8 plus 8, sorry,
Sir,
8
zero.
plus 8 plus 8 plus 0. Can you please count me?
24.
24. So this is nothing but a bit, 24 defining a bit. Now, can you tell me here in class B, why it is 16? Because the first
8
two
plus 8.
octet, see,
Yeah.
first two octet define, this is called actually a network bits. So your network first, like two, okay, so if you're using this network, for example, 172.16, so in your system, every machine will have first these two digits will be common. Similarly, if you remember in our lab, which I have shown you, so we use 192.168.10.0/24. So our machine IP addresses were 10.1, 10.2, 10.3, 10.4. Similarly, 20.1, 20.2, 20.3. So what does it mean? So it means, yeah, so first three octets are common. Okay, with define a network bits. Can you see? So these all 255 define a network bits, and the 0 define host bit.
Host.
So
Yes.
yeah, so now two more concepts are coming here: network bit,
Host.
and the host bit. Okay, so if you look at here in this class B, so what is the subnet mask of the class B? Can someone tell me?
255.255.00.
Exactly. That's why, and why why it is showing a 16? Because we have 8 bit plus 8 bit
Plus 8.
plus
Yes.
0
0 plus
plus,
0.
Yes.
so it
16.
it becomes 16. Okay.
Yes.
And class A. Now can you tell me the
255.
subnet mask?
255.0.0.0.
255.00.
कौन है भैया, ये कौन है, ये जो आंसर दे रहे हैं कौन है ये? Okay,
Nahid.
okay, 9. So okay, 255.0.0.0. Okay, and it is, that's why it's showing 8
8 plus 0
plus
plus 0.
8 plus
नहीं sir,
0.
0 plus
0 plus 0 plus 0 is equal to 8. Okay, so class A, class B, and class C.
Yes.
Okay, so can you please note down it? I'm just I'm pausing for 1 minute only.
Okay, sir.
Okay, I'm back. So now we understand that. And guys, if you cannot speak and you're getting shy, then please feel free to text the question because this session is for you. Okay. So, and you know what? I can directly go and jump into the slides, but I'm trying to give you some more basics here. Okay. Which so that you, when you go to the slide, you will clearly you will capture what exactly it is. Okay. So now private IP address, public IP address, then network based bits, host bit, then subnet mask, right? So we understand this all basics, and the ranges who own the IP address, IENA, and private IP address and a public IP address, and the classes class
Sir,
A, B, C.
IANA का full form क्या बोले आप? International Authority.
Can you Google it please and let me know
Mm.
quickly.
Okay.
I can tell you, but I want you to Google.
Sure, sir.
Internet Assigned Numbers Authority.
Very good. So got it? Achha.
Yeah.
Okay.
Thank you, sir. Yeah.
Or maybe you are testing my knowledge or what? इनको मालूम है नहीं है, लिखे तो बहुत बड़े उससे जरा पूछेंगे बोल के. Okay, ठीक है. So okay, fine, चलो, no problem. So till here, everyone on the same page?
Yes, sir.
कहीं दूसरों की बिल्कुल आवाज नहीं आ रही मेरे को. Where are others?
Yes.
Yes,
So,
sir.
and everyone they stop the videos and sitting in there और लेट के क्लास अटेंड कर रहे होंगे.
अकरम भाई की आवाज नहीं आ रही.
अरे लियाकत भाई को देख लिया. वाह. Okay, let me stop it for 2 minutes. Can you please open your cameras? I want to see what you are doing exactly. Okay, Nahid, okay, that's good. Okay, Anas, that's good. Okay, perfect. So no one is sleeping. That's good. Okay, Akram.
Yes.
Okay. That's fine. Okay, perfect. So it means that's fine. So I can see you guys are listening. Okay. So now let me share my screen back. Okay, so let's go to the submitting stuff. Okay. So before I start, so I would like to thanks one of my teacher, my friend who helped me to get my CCI, Mr. Atif Hussain. He built this subnetting, and he is a master in the subnetting. Okay, and he prepared this PPT, so I want to give this credits to him only. So subnetting. What is subnetting? So the definition of the subnetting. Look at here. Okay, subnetting is the process of dividing a single network into multiple networks. Wow, that's a subnetting. Converting host bits into network bits. So now you know that all 255, a number will be called as a host bit, network bit, and the 0 will called as a network bit. So host bit means 0 and network bit means 1s. So converting these bits is called a subnetting. So there are 2 types of subnetting. One is one is equal division, second is unequal division. So again, it will there are 2 types, FLSM and VLSM. What is FLSM? Fixed length subnet mask. And what is VLSM? Variable length subnet mask. Okay, so fixed length subnet mask. So can you by the name, can you imagine that fixed means what? What will happen here? Fixed means the subnet, what we build here, that will be fixed number. Okay. But in the VLSM, a variable length subnet mask. So you can choose, like you can define the number, how many numbers, how many machines you want. Okay. So that is the FLSM and the VLSM. These are the 2 major categories. So now let's have a look on the FLSM. Before FLSM, so IP addressing rules. Okay, so now In the network, each network required one network address, one broadcast address, and remaining addresses called as a host address. So for example, I have given this example like 192.168.10.0 is 0/24 is the network address. Network address is something a broader family number. Okay, so we are not using that 192 dot, let's say 168.10.0. Have you ever seen that IP address we use .0? Have you used any on any system? No. So that is our family number, that network address. This is called a network address. Okay, 192.168.10.0. It means the starting the .0 is a network address, and the last address of this network range is 192.168.10.255, where our IP address will be end. So this is broadcast address. So network address and broadcast address you cannot assign to the machines. So what left? 192.168.10.1, 10.2, 10.3, 10.4, like this till 254. This address is called as a host addresses. Host address means you can assign to the machines. You can assign to systems in your network. Okay. So this is a ground rule of any IP addresses. Okay. On any network. So now look at here. So this is something one network. Okay. So okay. So if you look at here, this router and below there is a LAN. Okay, switches you can see here. You can see the machines here. So this is a network one, which is nothing but our LAN one. Let's say it is our Hyderabad office. Okay. Then let's say this is a LAN 2. Let's say this is our Dubai office. Okay. So now, can someone tell me within my LAN what IP address range I will use? Or what IP address or what network I will use? What is my limitations?
You will use private network.
Perfect. Can I use 11 dot something?
No, sir.
No.
Yeah, you need to pay for that.
Yes.
Okay, let's say you have 100 machines, so you need to purchase 100 IP addresses. If you know, then you can use a private IP addresses. So
Yes.
from that range. Okay. So now this is an one network, your Hyderabad network, this LAN, this is your Dubai LAN. Okay. And this is the router. Okay. So now if you look at here, this is a third network. So this is actually called as a WAN network. So when you connect this router, so this net here also you need IP address in these two interfaces. Okay, this is called a WAN network. So now in this diagram we have three networks: 1, 2, and 3, and this all networks should be different. Like let's say 192.168.10.0 means it will be here only. 192.168.20.0 means it will be here only. 192.168.30.0, so it will be here only. So every network should have a different network address. Okay. So in this example, we have three networks. So even this connection is a network. It required network address, broadcast address, and two addresses for two interfaces. Can you see here? This is not a network. Actually, you don't have machines here. What is this? The WAN means what? Wide area network. So the ISP will give you connection to your doorstep, and here also ISP will give you connection. So it's like a wired cable they will connect from Dubai office to your Hyderabad office. So when you connect to the router, so you need an IP address on this router interface here and here. So here also you need another different network. Why? Here you need two IP addresses, and one will be the network address, one will be the broadcast address, and two usable host addresses you needed here. So in this network, you need 4 addresses here. Okay, got it?
Yes, sir.
Okay, so here maybe we can have 100 systems, 200 systems, so still we can use that. Okay, now this is the example, class A example. Can you see this? In the class A, when all the zeros, 10.0.0.0 means it's a network address. Okay.
Yes.
Then 10.0.1, 2, 3 till 10.255, 255, 254. These all IP addresses you can use for your systems. And this is your broadcast address 10.255.255. So in any network, you need minimum 4 IP address. Remember this point. If someone asks you how many IP address you required in one network, so the smallest network will be a WAN network, where you will have a point-to-point connectivity. So you need minimum two IP addresses. One will be the network address, one will be the broadcast address, and one side one IP address, another side another IP address. So like this 4 IP addresses minimum you require. Okay. So this is the class A example. Class B 172.16.0, this is the network address, and rest this all are the host address and the broadcast address like 255.255. So this, you can say this is the start, this is the end, and this middle you can use for your system. And class C network address, so you can use, let's say, see 192.168.1. Can you see here 1.0? So in the 1.0 you can create 254 IP addresses. If you can use 192.168.2.0, then again you can have a 254 IP addresses. So these IP addresses are like n number of IP addresses free there, private IP addresses. So you can see here the broadcast address of this network is, see, how can I see what is the network ID of class C? So the first 3 octet will be my network bits. So to my machines, this first three octet will be same. Okay, and this number will get changed. Okay, so class A, class B, class C. Now, default network mask. So as I shown before, the class A 255.0, class B 255.255.0.0, and class C 255.255.0. So this is a default network mask. So guys, you know what is meant by subnetting? Changing this default behavior according to your requirement is called a subnetting. यानी आप ये जो नंबर है डिफॉल्ट, इसके साथ छेड़छाड़ कर रहे हो. ओके, आप यहाँ पे जो सो 16 लिख रहे हो, आप यहाँ पे जो सो somewhere you are using here 8. Okay, something like this. You are doing some छेड़छाड़ there. Okay, or class A, class B, and class C. So that is called a subnetting. Based on your requirement, you are doing a subnetting. So now let's take an example. Okay, so before jumping on this slide, guys, look at here very carefully. Okay, and remember the points which we already mentioned before, that IP addresses are less. Ipv4 addresses are less in the world. Okay, you have only class A, class B, class C, and one networks are available free. Okay, now you need to save the IP addresses. That's the and that can be saved from the subnetting only. Okay, so without subnetting, how it look like? So let's have a look on this diagram. So now let's try to understand what is this. So this is your corporate office, okay, where you have 1,000 users. Okay, and let's say this is your Bangalore office, where you have 100 users. Delhi office, you have 30 users. Like you have mobile users, you have this much, and you have some 192.168 home office also. So within the corporate network, you have various branch offices connected there. Okay, now can you tell me what is this subnet? Which class it is?
Class C.
Anyone else?
No, sir. Class B.
Very good. And what is this subnet?
168. Sir, class B.
Class B.
No, this one.
Which class?
Class C.
Class C, sir.
Class C, sir.
Look at the first octet, man.
Ah,
Okay, and 10.0. What is
Class
this?
A.
Class A.
Class
Perfect.
Class A.
So now, if you look at the diagram, we can understand that when you have a more requirement, you will use class A, because class A, you can see here, the network bits are only 8, but 24 bits are host bit. So you can use this many numbers there. In class B, the network bits are a smaller one. Okay, two only, but 16 bits are host bit. And in class C you can have. Okay, now you can see 1,000 users you can create in the class A. Are you able to create 1,000 users in class C? Can someone tell me how many maximum users you can create in class C? Just look at this number.
255, 0 to 255.
This is your network 192.168.1.0. So remember, just remind yourself for the network, the requirement network ID 1.0 is my network ID. What will be the broadcast ID? 1.255 is my broadcast ID. What left? 1.1, 1.2, 1.3, 1.6 till 154. So how many it become?
65,000.
Oh, no.
0 to 255.
Just count it, right? Class C. These three are common.
254, sir. 254.
Right. This is the correct answer.
255 to 54.
Right. So you can say 253 actually. Why?
Okay.
Because the 0 we are using here and 255 is a broadcast. So you can use this many machines. So can you tell me, if you have 1,000 users, are you able to use the class C there? No.
No.
So that's why if you want more users, if you have larger organization, we use class C. If you have mid-level organization, it will be class B. And if we have small organization within a 200 or within we can say 200 or 250, then we will use a class C. Okay. And as I told, in class A, like class C, we can create this many users. So can someone tell me in class B, let's say it is a /16. Okay. So how many machines I can assign IP address in the class B? You can do the
65,024.
very good. 65,000 and
Wait, yes, sir. 25, sir. 65,025.
okay. See, 65,000 machines you can assign IP address in the class B. And can someone tell me in class A how many IP addresses I can assign? Google it.
1 crore 65 lakh 21,375.
Exactly. Yeah, true. So this is your number. So now tell me, in your PSF office, how many systems you have? Okay, 16. Let's say 16 system. And we have a Wi-Fi. So users may be
18.
connected into the Wi-Fi.
Class
So let's
C.
say maximum 50. So which class you will use there?
Class C.
Class C.
Obviously, class C to save the IP addresses. Okay, now let's run this slide and let's understand. Okay, now if you look at here, with the default behavior in the Bangalore office, if I'm using class C, so I have a 254 IP address, so minus 100, which is my users. So how many addresses I wasted? 154. Next, in Delhi, I need only 30 IP addresses, but I use a class C 192.168.1 dot something. So which can, with that I can create over 254 IP addresses minus 30. How many IP addresses I wasted? 224. Next, okay, can you see the WAN link? So here I need only 2 IP addresses. Okay, but out of this, how many IP addresses I wasted? 254 IP addresses I wasted here. When I'm using this 192.168.5.0/24, when I'm using this network for this particular link, where I need one IP address here, one IP address here, that's it. So for these 2 IP addresses, I wasted 252 IP addresses, which those IP addresses I cannot assign anywhere in my organization. Okay, next. So can you see here in the home, I only needed 2 IP addresses. I still use the class C. So I again wasted here 252. And the look at here. I was needed only 3 IP addresses and I use class C. With that, I can create 65,000 IP addresses. And can you see how many IP addresses you wasted? 65,531. And look at the big number here. 1,67 lakh 77,214 IP addresses can be made from this range 10.0.0.0/8. So out of that, I use only 1,000. Can you see how many IP addresses I wasted? 1,67,076. Oh, sorry, 1,67 lakhs 76,214. ये डिजिट बोलने भी मेरे को जैसा जबान लड़खड़ा रही, आप लोग इतने वेस्ट कर दे रहे हैं. Okay, so and you know what? Once you use the 10.0.0.0 in your headquarter, you cannot use this IP address anywhere in your network. And these all are private IP addresses. Okay, you cannot use in any other network.
Yes.
So it will be within that office only. But see how many IP addresses you are using, wasting there. So this is without subnetting. This behavior is without subnetting.
Subnetting
That's-
is the poor solution.
Exactly.
Hmm.
Subnetting is the solution to save the IP addresses. यानी आपकी जितनी जरूरत है उतनी लो भाई. Okay, what is the requirement? 100 है ना? ठीक है चलो. Not exactly 100. 120 ले लो. एक 20 extra रख लो. बाकी we can save it for the future. Right? Right. Subnetting हमको सिखाता कि saving कैसा करना. Because see, look at the requirement. Okay, here I need for the WAN link, I need a 4 IP addresses only. So I wasted 252 IP addresses. So I need some solution where I can use only this IP address and rest all I can use somewhere else. So that procedure is called as a subnetting. समझ आई बात? सिर्फ एक को समझ में आया.
Yes, sir.
Okay. Now, how to do the subnetting? Okay. So before understanding a subnetting, you need to understand the power of 2. Okay. So 1-bit binary. So see, binary means what? Zeros and 1, right?
Yes.
So 0 and 1. So the value of 2 is 2 raised to 0 is equal to 2. 2-bit binary means 2 raised to 2 is equal to 4. 3 bits binary means, can you see here? Two binaries, 3 binaries, right? So the 8 values, like 2 raised to 3 means 8. 2 raised to 2 means 4. 2 raised to 0 means 2. Okay. 0. Okay. So now look at the power of 2. So how the power of 2 is look like. So see our IP addresses, when I say 1 octet, okay, let's say 1 into 168.10.10. So 192 is the first octet. Okay. And how that number came? Can you see that number came by adding these bits? Okay. So these are the number. So the power of 2 is used there. So any octet, we will have a power of 2. 2 to the power 0, 2 to the power 1, 2 to the power 2, till 2 to the power 7. So first look at the numbers here. 2 to the power 0 is equal to 1. 2 to the power 1 means 2 into 2, 2 into 1 is equal to 2. 2 into 2 is equal to 4, 2 into 3 is equal to 8. You can just multiply it. 2 into 7 into 2 into 7 means you need to add, multiply 2 into 2, then 2 into 2 into 2, like this 7 times. So 128. So these are the numbers. So if now we need to change these bits, then only we can do the subnetting. So now look at here. How the 0, see, this is a decimal number and this is the binary number. So 0 means 0. Can you see here all zeros are 0. 1 is 1. So 2. Why the 2 came here? In this range, I'm using this 1 means it represent this value. Okay, and here I use I have a 3. 3 means what? Addition of this 2 plus 1 is equal to 3. So this is a 1 octet. When I say 3 dot 1 dot 1 dot 1, one of the IP address. Is it a public or private IP address?
Public.
Sir,
Okay, 3 dot 1 dot 1 dot 1. So 3 means how the 3 is actually, it is into the binary format and it look like this one. But in the IP address, we use a decimal number. So the power of 2 is very useful. 1, 2, 4, 8, 16, 32, 64, and 128. So let's have a look more example. So if 3 bits are changed, let's say, for example, you are changing a 3 bits. So you need to count something like this. So 1, 2, 3. These are the 3 bit change. So 2 raised to 3 is equal to 8. 2 raised to 4. You are changing 4 bits. 2 raised to 4 is equal to 16. So you need to add this all plus. Okay. Next, 6 bits you are changing. So it will be 64. And the last is 128. So now 2 to the power 7 is equal to 128. So this is a power of 2, which use in a subnetting. Okay. Now look at here one more example. Subnet mask. So let's say example here. Okay. Class A and class B and class C. This subnet is a default subnet. Okay, default subnet mask. So how this 255 become? Can you see this all 8 bits are 11111. Why it is 11111? So 111 means if you count this 1 means this all are 1 plus 1 plus 1 plus 1. And if you add this all, can you someone add please this one? Can someone add 128 plus 64 plus 32? How much?
255, sir.
How much
255.
it is? Perfect. So this is how the default subnet mask is going on. So 255 is representing this one. And 00 represents all the zeros. In the class B, it is a slash like 255.255, right? So all are ones, rest all the zeros. And class C, all 3 octets are ones and 1 octet is are 0. So can you see here, if we don't use a decimal number in IP address, how difficult it will be, right? So that's why decimal number is we can understand very clearly. Okay, and the decimal number, as you know, देखो ये पूरा IP address का जो खेल है ना, the numbers between 0 to 255 only. Okay, and the background you have these all rules and all, class A, class B, class C, or is the network host. Okay, so now if you look at here, the blue color, all ones called as a network portion. Okay, and rest all are the host portion. So now tell me, I have a question. In which class I can have maximum number of users? Can you tell me?
Class A.
Class C.
Class A.
Class.
Class A.
Okay. Why class A? Because the host portion, can you look at here? The host portion is available this much. Host portion, host portion, host portion. Okay. That's why you can have maximum number. In class B, you can have a less. And can you tell me in which class I can have a less number?
Class C.
Class C. Why? Because it has
Only
only
one host.
1 octet is a host, like 8 bits are host only. Rest 24 bits are network bit. So which cannot be changed and that will be fixed. Okay. Next. So let's see a class
खाली है
C.
ना लेफ्ट साइड का.
Okay, now please go on mute. Okay, now let's have an example of the class C subnetting. अगर आप एक subnetting का भी example समझ गए, class C का हो या किसका, then you will understand many things. Okay, so as I told, like we need a basics on this level. Okay, we are not expecting you become an expert here, because as I told, we have a career path for this. You can become after CCNA, you can do a CCNP, you can do a CCI till that level. Okay, but understanding of IP address is very important because in your resume you are going to mention that I know I have the understanding of the IP addresses. Okay, so now look at here the class C. Okay, so now let's say class C example based on requirement of host. So let's say I have a requirement of 100 host. Host means machines. So मेरे मेरे organization में 100 machines है. Okay, I have 100 machines and I want to use that machine. So with the subnetting, I can achieve something like this. Can you see this? This /24 becomes /25, and this is become a separate network, and this become a separate network. So here I can use, he can achieve the 100, and this one I can reserve for others. And how we achieve this one? By using a subnetting. So let's have a look into this example. 100 host, 100 machine है मेरे पास, and मेरे पास IP address है 192.168.1.0/24. And if I use that /24, I'm going to waste 152 IP addresses, 153 IP addresses, because my 100 requirement. But I want to save it. How can I do that? So now class C ka default, what is the default mask of class C? Okay, so we know that 255.255.255.0. So now one network bit, like you have one network bit only. Okay, required 100 host, address vested 256 minus 100, 156 your address, vesting the address. So with the subnetting, you can achieve something like this. So this will be your broadcast address, and this will be your so, okay, can you see the subnet mask will become change here? When you do the subnetting, the subnet mask will become 255.255.128. So when you and the slash will become a 25. 192.168.1.0/25. It will become a 25. So what does it mean? So you are changing, as I told, हम subnet के जो bits है उसके साथ छेड़छाड़ करने वाले. Like we are from host, we are converting host bit to the network bit. So that is the subnetting. If you look at here, see default, how many host bit we have? 8, right? So what we are doing, we are borrowing one of host bit, we are converting into the network bit. Then it will become 128. Okay, and how it become 128? So in this example, it will let you know. So now this is the first formula. Okay, what is the first formula? Is 2h minus 2 greater than is equal to required host. आपके पास आपको requirement कितनी है? Maybe it's a 200, maybe it's a 150. Okay, and always I'm telling you, go with the small example. Okay, direct जो 1000-2000 IP address लेके उसके अंदर confuse होके मत बैठ जाओ. Okay, just take it very simple. Take a class C. Okay, and now here we required 100 users. आप जो 40 ले लो, आप जो 60 ले लो, and you can do the same calculation and you can achieve something there. Okay, now see, I'm telling you, if you are not from the maths background, if you are like you don't know about the binary and decimal, then sorry to say this, you will not understand this. Okay, and you need to learn the basics of the maths. Okay, that's what the minimum qualification here is, graduation. So we are expecting every graduate, they know about the numbers and the binary digits and all. So this is just an example I'm talking about. Okay, so now the first formula, host per subnet, means how many hosts you needed per subnet. So this is the formula. Okay, so now 2 to the power h minus 2. So h, what is mean by, first you need to find the h. What is the h? H is nothing but you need to see where this h is coming from. So 2⁻⁷. So 2⁻⁷. So can you see 100 means, are you able to achieve the 100 number with this 2 to the power 6? No. So are you able to achieve this with the 128?
Yes.
Yes. So that's why we got the h value. The nearest value you need to see. At least it should be minimum, maximum. But if you choose 64, then you cannot get 100 IP addresses into that. So now we choose /26. So now you find out the H. So H value is this one. So host per subnet. So 128 minus 2. So you can get 126 IP address in one network. So this is the first thing which you need to identify. Host per subnet. So host per subnet, you will your requirement is 100, but we cannot give you 100 exact. So maximum we can have is 126 will be there. 126 IP addresses will be there in your host. Now the next question. So now I can say the host bits required H is equal to 7. So now what we need to do, we need to understand the borrow network bits. So small n we need to identify, which is nothing but the total host bits minus required host bits. So now if you look at here, what is the class A total host bit? 8. And what is your required host bit? 7. So 8 minus 7 is equal to 1. So guys, you need to borrow one network bit from the you need to borrow one network bit, and that's why your slash notation will be something like this: 24 plus 1. If you're borrowing 2, it will be /26. If you're borrowing 3, it will be /27. But look at here, what you understand, the H is nothing but the value which we identify from the power of 2. Second, you need to find out the how many host bit, how many network bit you needed. So the formula is total host bits. So in class C, the total host bit will be 8, because we have 255, 255, 255. All ones are nothing but the network bits, and we have last are the 8. So 8 bits minus 7, so is equal to 1. So you need to borrow one network bit to achieve this subnetting. So and your slash notation will be look like /25. Why? Because 24 plus 1 you added here. So these are the three formulas. This is the first requirement, okay, host bit. Then second is you need to identify how many bits you need to borrow, second requirement. And the third is, now we got the value of n. N is nothing but the network bits, so which is nothing but the 1. And the slash notation is nothing but the /25. So these are the first 4 formulas, and you can get this. Next. So now how we did a subnetting. Now we need to borrow one network bit from the host bit, right? So how it will be look like? See, our default subnet mask has by default 000. So now when you borrow one network bit from the host bit, okay, which is nothing but the value of n, so that you can see it's a blue color, and rest all of the 0. So you know what it will be. So it will, this is 1, because rest all will be 0, only this one, and this 1 will represent 128. That's why our subnet mask will become 255.255.255.128. This is our subnet mask.
Yes, sir.
Okay. Next. And our slash notation will be 8 plus 8 plus 8 plus 1 is equal to /25. So now you got the subnet mask, you got the slash notation, you got the network bit, how many you need to borrow, and all. Okay, now the next thing, by taking this, now you need to gather this all thing. Okay, see, host per subnet. So now, as we know, we will have a 126 host per subnet. How many subnet we will able to create subnetting here? So 2 to the power n. This is the another formula, the formula number 5. Subnet is equal to 2 raised to power n. 2 raised to power n is nothing but 2. So in this network, I am going to build a 2 subnet. Actually, I have one subnet, right? 192.168.1.0. So that I'm splitting into 2 different subnets. Okay. And this one subnet, it will be having 254 IP address. So I'm dividing that into 126 plus 126. Yeah, 2 subnets. Okay. And your slash notation notification like the subnet mask, customized subnet mask. Can you see this? Customized subnet mask. So whenever you see slash something odd, so that means that's a subnetting. If you see /8 /24 /16, it means that is a default subnet mask of any class. Okay, so now the range will be something like this. Your network started, your first network will be 192.168.1.0/26, and you know what, how you need to create it? Okay, see, you need to write down 192.168.1.0, and what is the next IP what is called 128. So you need to write down that 192.168.128 here. And what is the last number before 128? 127. So you know what? This is a first network where the network ID will be 192.168.1.0/26, and the its subnet mask will be obviously 255.255.128, and you can and this will be the broadcast ID 192.168.1.127, which is nothing but a last host. Okay, last host, and you cannot use that. And the next range will, what you can do is you can take this subnet where you are having 126-bit, and you can use into your LAN. Let's say LAN 1, you utilize that, and you reserve this one. And tomorrow you have another office, so another VLAN, so you can assign this subnet there. Their range will start from 192.168, 1.129, 120, something like this, 130, 150 till 254. So you divided actually that broader subnet, you divide into you split into the two subnets. So this is the class C example. Okay, this was the basic class C example where 192.168.1.0, it was a network address. 192.168.1.255 is the broadcast address, and rest all were the 1.1.1. So this was the default behavior, default subnetting. And when you do the subnetting, so what is the subnet mask become 128, and the network address will be look like something. Network address will be, first network address is this one, and broadcast address is this one, and all usable host will be this one, 1.2, 1.3, 1.4 till 1.26. Okay, this is your first network. And the second network, the ID will, network ID will be 192.168.1.128. This will be your network ID. Okay, don't say that always 0 will be your network ID. No, if you do the subnetting, 128 can become the last digit can become your network address, and your broadcast address will be the last one. And you can have this many IP addresses. See, it start from 1.129, 130 till 254. So here you got 126 IP address, here you got 126 IP address, and your requirement was 100. So you use this one and you save this entire network. This is a subnetting. That's what the objective of recording this session is. You can go and watch it again. Okay, and I'm going to share you this PPT as well. Okay, so you can refer it and try to understand this one. Okay, because see, I cannot simplify more than this. This is the maximum simplification I can do. अभी भी समझ में नहीं आया तो sorry, I cannot do anything, because ये इतना ground से जो सा आपको I'm trying to explain.
सही में नहीं आया तो समझ में.
हाँ, that's good. So it needs some more time. So आपको जो सा आपको अगर ये lecture में समझ में नहीं आया, so I'm telling you, you watch this video for 2 to 3 times. Definitely you will understand this. Okay. Okay. Now, how many of you understand? Can you tell me?
Got it, sir.
Partially.
Okay. Okay, that's good. So at least you got some basics, fundamentals, like how the subnetting will happen. Okay. So now we have one more example. So now अब आपके पास formulas हैं. Okay. Now let's you do it. we have a requirement of host 40. पहले कितनी थी requirement 100 थी. Okay, and the same subnet. So network is the same 192.168.1.0 same network. Okay, now the requirement got changed here 40. यानी आपको ऑफिस में 40 machines चाहिए. So let's do that. The first thing, 2 to the power h minus 2. So आपको 60 machine if you want to achieve, then which power you can use?
2:6.
Exactly, this one we will use. Okay, so instead of 60, at least you will get 64 IP addresses. Okay, now you got out of 60, you host per subnet. Yeah, means in your subnet. Okay, now see here, 64 minus 2 is so in your subnet you will have 62 IP addresses. Okay, now the host bits required. So h is nothing but the 6. So now how many network bit you need to borrow? The total bits, which is 8 minus
8 minus 6.
host, so 2. So aapko jo so from host bit you need to convert 2 bits to the network. And can you see, if the small n is a 2, then /26 it becomes /26. Previous example mein it was /25.
1.
/25. Yeah, 1. Now slash. Now tell me one thing. If I say /27, और छोटा होगा नेटवर्क आपका. आपके नेटवर्क ज्यादा बनेंगे उसके अंदर, and your host requirement will be less. आप उसको 20 कर लो.
24.
You can do this practice. आप 20 की example ले लो and try to do it, applying this formula. Okay. So /20. So now you understand the how many bits you need to borrow. So how you will borrow? See, this is our base setup 1.2. Like all zeros. So we are borrowing this first 2. So 128 plus 64, it will become your subnet mask. Now see, your subnet mask become now 192.255.255.192. In previous example, your subnet mask was 192.255.128.
128.
was there. Now your subnet mask become different. 192. And your slash notation will be 8 plus 8 plus 2 ले रहे हैं ना आप. So okay, so /26. So now we got 62 host bit. Then we got, okay, how many subnet we can get? So n is nothing but the 2. 2 to the power 2 is equal to how many subnets you are able to see. So 4 subnet you are able to build here. So can you, what are those subnet? These are the subnet 192.168.1.0. So आपके maximum कितने होंगे, like 63, right? So this is your end 64. Then what you can do is you can directly plus it 128.192. So and you can minus from here 64 का एक minus करो 63, 128 से minus करो 127, 192 से ये start and ये end, start end. Like this आप जो से you have made a 4 different networks of 62 hosts, and you can use one network for one VLAN and you can reserve this
3.
So like this you have saved the IP addresses. Okay, so guys, this is a subnetting. Okay, और आप अभी like we have seen only class C subnetting. आपके लिए future में you can, if you want to become a master, then go for the subnetting. आप you can go for the class B subnetting, class C subnetting, which will be huge. Okay, so now this will be our network, like 4 networks we will have. This is 1 network, 2nd, 3rd, and 4 network. So if you, now the second example, if you take the 3 bit, what will happen? 224. The subnet mask will become 224. If you borrow the 3 bits, /27. Yani आपके /27 means you will have a, and if you take the 4 subnet mask, how many it will be? If you take the 4 bits, it will be 240. And if you take the 5, see, it's the next examples actually, 248.
248.
And similarly, if you borrow 6 bit,
252.
Exactly. कौन है ये? Nahid.
जी सर.
Perfect. So now this is the table. Decimal notation, binary notation, and the slash notation. See, slash 27 means what? What is happening? 224. This will be your subnet mask. 192. The last octet. 128. We took the example of this one, right? All other values are invalid. See, this value is invalid here. Slash 32 we cannot use. Slash 32 because it will be all other network bits. Okay, you cannot use that. So now, so
Sir,
this
what
is,
about that invalid submask subnet, the 254?
yeah, invalid subnet is something. 254 means you will have only in this subnet. See what 0 represent? The first 0 represent 1.
Oh yes, one.
And to make one network, how many IP address you needed? Minimum 4.
4 IP address.
Minimum 4. So
Yes.
you cannot, that's why it's invalid. यहाँ पर सिर्फ आपको एक ही IP address मिलता. But if you look
Okay.
at the second example, here 2 to the power, okay, and actually 2 to the power 0 is equal to 2, 2 to the power 1 is equal to like here यहाँ पर आपको देखो ना यार यहाँ पे है 2. So
Yes sir, we'll getting 2 over there.
yeah, so you can use the slash 30. देखो जितना बड़ा नंबर रहेगा उतने कम IP address रहेंगे. That's a best example. Slash 30 यानी आपके बहुत कम यानी 4 IP address मिलेंगे आपको. यहाँ पे आपको 16 IP address मिलेंगे. यहाँ पे 32 like this. So you can go into detail. So see, this is the example. Like आपको 256 का subnet है ना, आप इसको divide करके you can make it 128. Or you can make it 64 के 4 बनाओ या 32 के बनाओ, then 16 के बनाओ, then you can make it 8, then 4. ये 2 के तो नहीं बना सकते. Okay. So this is how we can make it. So subnetting can be done on some more examples are there. You can just go with this 2000 host. So this is a class C subnetting. You can go through with these slides and see these are the same formulas. If you understand the class C, then you can make any subnetting. Class A का भी बना सकते. But can you see in class A how many subnets you are able to see? And if you look at here, just an example, see in class A example, 892 subnets you are able to make. Class A के अंदर 800. So can you try to आप पेन और पेपर लो, आपका पूरा पेज भर जाता, पूरी नोटबुक भर जाती है आपकी सिर्फ क्लास A की सबनेटिंग में. Okay, so see class A, you can see the slash notation. How many subnets and what will be the subnet mask? Okay.
Sir,
So-
इसे memorize करना है.
No. See, you can take the chart and put it into your desk somewhere, and you can just keep practicing into that. Like how, like based on your requirement. What is your requirement, and which subnet is suitable for you, so that you can not waste the IP addresses. That's the objective of subnetting. Okay. Now, VLSM बहुत आसान है. FLSM you have the formulas there. But VLSM आप देखेंगे तो you will be very happy. So before I end, I want to make you happy. VLSM, what is the VLSM? You have 60 users, 30 users, and some 100 users. So /26 /26 /26. So this is actually the example of FLSM. So in the previous example, if you remember, with the FLSM, what was happening? All the subnet was having /60 one subnet only, one slash notation, common slash notation. So अगर आपके पास if you are 60 users, so if you have 30 users, तो वहां पर आप 30 IP address waste कर रहे हो. So to fix that problem, FLSM problem, VLSM came into picture. See, so subnet mask, so block size rule. So what the block is, the IP addresses blocks are something like 0 to 128, then 0, 64, 128, 192, 64 block, 32 block, and the 16 block. What is this block is something like this. If you need a 60 IP addresses, then you can use a 64 block. You need a 2 IP address, you can use a 4 block. Yani WAN link ke liye. So if you need like a 6 IP address, you can use a 8 block, 16 block. So use that block, and rest everything, all blocks will be safe for you. Okay, now look at here. FLSM, in a FLSM example, your all subnet was equally divided, all network was equally divided. But in VLSM, okay, now see, in the FLSM, this is the example. But in the VLSM, you can divide it again. Can you see? Can you look at the subnet mask? See?
Yes, yes, sir.
So based on your requirement, you can use, you need a 4, right? So see,
Yes.
this is your IP address block. Okay. So in that, you can just, you're just using this block, and rest all the blocks are free. So VLSM is something very you can use as your requirement. VLSM also, you can, as per your requirement, you can use it. So this is the table of the VLSM, 0 and 4. So you need minimum this one. Okay. So let's say, so if I say, if you want to use a slash, if you want to use a 64 block, then your default subnet mask, your IP address is start from 192.168.1.0 to 192.168.1.63, and your slash notation will be fixed /26. आपको 60 machines है. Okay, you have used this block, यहाँ से लेके यहाँ तक 64 तक 3 तक, then this block is freeze. Tomorrow in another branch, you need a 32 IP addresses only. So from after this 163 तक ये थे आप, now you started from 64 to the 95. Can you see the table? The next digit is 96. So take the last one, 95. Before that, that will be your broadcast address. This is the subnet network address, broadcast address. The IP addresses will be 65, 66, 67, like this. Next, you have 4 requirement only. Can you see? You can use something like this. See, the next range is starting. Network ID is 96 and the broadcast is 99. So what IP address left? 97 and 98. 2 IP addresses are used. 4 again. Remaining addresses fail. See, let's say today you have 4 offices. You use these subnets. That's it. So rest all blocks are still vacant for you. Now, can you tell me, tomorrow I'm having another office with the 4, like I need another WAN link for the 4 IP address. What will be my network ID? Can someone tell me? My network ID will be the next address from here.
1042.
Exactly. 192.168.1.104. It will start from here, 104, and it will end on 107. So the valid IP address will be 5 and 6 only. Slash notation will be /30. So now with the FLSM, okay, see, this was the FLSM which you vested, and with the VLSM example, you can see, you can have a 10 user, 20 user, 8 user, 6 user, 30 user. So just try to use the FLSM, that table, and try to build the network. That's it. You don't need to go for the formulas and all. See, this is a table. Use it. See, the example is given there. 16, 16, you're using 32, then you're using 64 block, then you're using 16. And it doesn't mean that you're using a sequence. You can break the sequence. See, here we break the sequence as well. See, we use this, that's it. And rest all we reserve for the future. See, we did not use this one. This entire block. This one we did not use. You can use it later. So now see, you assign the subnet. See, within a 192.168.1.0, that's you can look at here. The first octet is 3 octets are common, but they all are the subnetted separate networks. See, their slash notations are different, their network IDs are different, but the first three are the common. So it means we did a subnetting by using the VLSM. See, 2 options you have. Either you go for the FLSM, go for the VLSM. Now 2 choices you have, and the objective of the subnetting is effective utilization of the IP address and without wasting the IP addresses. That's it. Shortcut to subnetting. So there are some like if you are using the FLSM, there are some more table captured here for class B, C, and C. Look at here, 172, the second octet, third octet. So you can see that that IP address like 172, third. So some more things are given there, but that is enough. So let me see how many are sleeping there. Can you please switch on your cameras? I'm done. Subnetting khatam. कितने लोग सोए हुए हैं और कितने लोग होशियार?
नहीं सो रहे सर, सब होशियार है.
But I see some less numbers here. Okay, so now अभी बोलो, how is the subnetting? लियाकत भाई.
Good, sir.
अच्छा, हाफिज आपका नाम अदनान ना?
अनस अनस.
Anas, Anas. So Anas,
जी सर.
FLSM is good or VLSM is good?
VLSM
VLSM, good.
easy.
Shoaib,
जी सर.
FLSM or VLSM?
VLSM.
Okay, but you need to know the FLSM as well. So subnetting, as I told, this is not a matter of one lecture. Okay, इसके ऊपर n number of classes हो सकते हैं where you can do the calculations based on different requirement, different host के numbers लेंगे. But the examples which I have given, that is more than enough. Okay, where at least you will come to know what is the slash notation, what is the network address, what is the broadcast address, what is the default subnet mask. So this, if you understand this all, and with the PPT, if you can able to just take your own example, like your host bits are 20. In the same 192.168.1.0, take your requirement is 20 and try to do the subnetting. If you are able to achieve that, then you understand the subnetting. No need to go for the class A and class B because it will be a bigger number. And nowadays, there are online tools also, just for your information. Online tools there where you can use that tool, and that tool will do the subnetting for you. Okay, some URLs are there, so that I don't want to show you that now. Otherwise, you will get lazy. You will say, "Oh no, we got a shortcut." So the better is try to do this FLSM and VLSM and do practice, and this is more than enough to understand what is the network end. Okay, so with that, we'll stop here and we'll continue later.